All right, guys, lesson 4.6. We're moving on to angle bisectors on triangles. We're kind of getting towards the end here. I think there'll be probably 3 more sections in this chapter. Okay, so angle bisectors, now we're looking at angle bisectors on triangles. You will need your protractor. You also need your compass. Hopefully you didn't lose your compass. If you did, you need to get 53 cents to Alex S. Thalen. He's my accountant, and he will get that 53 cents to me, and I will get you a new compass there. Okay, so you're going to be given this triangle to draw. Let's just say 30, 70, it's at 100, and then so we need 80. So they'll give you the angles, draw it out, 30, 70, 80. They're not going to tell you the size. You can make whatever you want, but make this triangle fairly big. It will be easier if it's bigger. So I'll put the 30 over here, I guess. And I'd like it to be even bigger here. Maybe I'll put the 70 over here. And then that top angle should automatically be 80, right? Because they need to add up to 180. So looking at this. Okay, and then it'll say draw the angle bisector of each angle and find where they meet up at, basically. Okay, so angle bisector, remember we just cut each angle in half. So instead of 30, I'll go to 15. So roughly right here, cut that angle in half. 70 cut in half is 35, right? So instead of 70, I'll hit here at 35, right there, between 30 and 40. And then 80 cut in half. See how good I was on this 80. Eesh, not too great. Eesh, that's pretty bad, but I'm off by a few degrees there, but we'll go with it. 80 cut in half will be 40. So trying to get as accurate as you can with these, but it is hard to be exactly accurate unless you're really careful. Okay, so I cut each angle in half, so it's kind of like this. Cut in half like that. These two are equal, and these two, I'll do a triple mark, are equal, right? So each angle got cut in half. They will meet up at a single point. Okay, so where the angle bisectors meet at, it's called the incenter. That's kind of your new vocab here for today, at the incenter. Okay, which is right there. Okay, that's the big thing. It'll always be kind of like in the middle of the triangle, you could say. The other thing is this is the other big thing. Incenter is right just below there. Equidistant or equidistance, you could say, from the sides of the triangle. Okay, so this point is equidistant to each side on the triangle. Here's how you can show that. This is where we get our compass out. So if I take my compass and make a circle that's centered right here, that circle, I should be able to make a circle that just touches each side, so that this distance here to this side is the same as this distance to this side and the distance to this side. If you can imagine, I can make this circle where the radius of that circle is how far it is to each side. Okay, so how do you do that? Well, you center it here, and then I'm going to pick the hole that, man, it's going to be right, oh man, it's going to be this one. For me, it's going to be this one here. I'm going to try to pick the hole that just touches the side there, and hopefully my pencil is sharp enough. Oh man, I got a sharper pencil here. Yeah, this one might work better. So this hole here just looks like it's going to glance aside. So if I take that around all the way, yeesh. Okay, yeesh, that was bad. It should, and it was doing it until I got off, it should touch each side. Just a move, it's moving on me a little bit weirdly here. It's not spinning nice. Okay, but it should. I'm trying to make a circle that just glances each side, but it keeps moving on me at the end here for some reason. I don't know what's going on. It's getting stuck. Okay, but I'm looking for this circle that just glances each side. Okay, see here? I'll fudge it a little bit, but you can see that circle should just barely hit each side and not go outside, not go in. Okay, so that's showing this equidistant. Okay, because if I would measure the radius on the circle, you can see, you know, it's basically 2 centimeters here. You don't need to draw this on yours, but basically it's 2 centimeters there. If I measured to this side, it would be, you know, basically 2 centimeters, basically 2 centimeters. So it's like the radius of that circle just hits each side. Okay, that circle fits inside. Remember on that, that game you guys did, the eyeballing game, there was this scenario where it said, hey, make a circle that fits inside, or find a point that's equal distance to each side. And it basically was making this triangle that, or the circle that fit inside the triangle. Okay, but that's this. Okay, and basically you just got to draw a few of these on your homework today.